Hello everyone. In this video we're going to continue our investigation into immediate inferences and have a closer look at some of the types of immediate inference we can make with categorical logic, and we're going to explore in a little bit more detail the Venn diagram tool that we looked at last time on the traditional interpretation of logic. So to move along here, just as a little bit of review, recall that on the modern interpretation of logic, there are essentially four categories of proposition, right? And we've learned how to sort of locate those on the square of opposition and then to make some immediate inferences on the relations between those categories. We now have learned the Venn diagram tool as another way of visually representing the relationships of the categories of proposition to one another. On the far left, we have, on the modern interpretation, our universal affirmative, our A propositions, all S or P, where we have shading in region 1 to indicate that there is nothing out there, as it were, in the statement, and that every member of S is also a member of P. For region for the E proposition, the universal negative, we have shading in region 2 to indicate that there is nothing in the area of overlap between the subject class and the predicate class. In the particular categories, we have for the I proposition and X to indicate the belonging of at least one member of S that is also a P. So some SRP we place as an X in region 2. So to distinguish the universal from the particular, where the universal uses shading, for the particulars we use an X. And then finally for our O proposition, we learned that to indicate some S are not P, we put an X in region 1, which is the subject group, to denote that it is definitely outside of the predicate group. Okay, and this occurs on page 199 of your Baronet textbook if you want to refer back to it. Okay, now I want to have a look at how the traditional interpretation of categorical logic uses the Venn diagram to symbolically represent the four types of proposition. So recall from last time that the major difference between the two interpretations has to do with this category or this concept of existential import. And the question there was whether or not the class terms really in fact exist in the real world. On the modern interpretation, we suspended judgment about existential import. In other words, when it came to universals, there was really no judgment made about whether or not the universal class term really does exist or not. In the traditional interpretation, however, that is the Aristotelian tradition, we do make claims about the existence of universals. And so we need a slightly different style of symbolic representation to indicate that on the Venn diagram. So this is what our A propositions are going to look like on the traditional interpretation of logic. Remember, the A proposition is our universal affirmative, all S or P. And so, like the modern interpretation, we're going to use shading in region 1 to indicate that there is nothing out here in region 1 in the subject class that is totally apart from the predicate class. However, the difference now is that we need a X with a circle around it to indicate the existence of at least one member of the subject group that is also a member of the predicate group. So the distinguishing feature of the traditional interpretation here is to indicate the existence of at least one member of the universal. And we do that by marking region 2 with a circled X. Okay. Now if we move forward and look at our E proposition, the universal negative, no SRP, like the modern interpretation, we are going to use shading in region 2 to indicate that nothing is in that area of overlap between S and P. That is the meaning of the proposition. However, to indicate existential import, we are going to use a circled X in both region 1 for the subject group and region 3 for the predicate group. And that indicates that there really are existential members of the subject and predicate groups in this proposition here. We are actually making a claim about the existence of at least one member of the subject group and one member of the predicate group. So still shade in the center in region 2 to indicate that there's nothing in that region. No S is a P, no P is an S. However, we need the indication of a circled, of an X that is circled in S and P, region 1 and 3. The good news is the particulars are going to be exactly the same because the question of existential import only was a question about the universal categories. With particular categories, our I and O propositions, the notation on the Venn diagram is exactly the same. So for our I proposition, our particular affirmatives, some S or P, we are going to use our X once again in region 2 to indicate the existence of at least one S that is also a P. No need for a circle here. The existential import question really is just a question about universals, and we're dealing with particulars here. So this is identical to the modern interpretation. Some S or P is symbolically notated on the Venn diagram in region 2. For our O proposition, this is again the same. Some S are not P, the particular negative. This takes the same form as on the modern. We need an X out in region 1 in the subject group that is definitely excluded from regions 2 and 3 to indicate that the member of the S group is definitely not in the P group. And that's what the meaning of the O proposition states. Okay, so now we have two different representations really of our categories of proposition on the Venn diagram. And the purpose of the Venn diagram really is to allow us to get a visual representation of the membership of classes of things on our 4 categories. Remember, categorical logic is really about the membership of classes of entities with respect to one another, from which we can then make certain inferences that are immediate. So here's the full list of propositions on the Venn diagram for the traditional interpretation. A group has shading in region 1 and a circled X in region 2. For the E proposition, again, we have shading in region 2 and circled X's in regions 1 and 3. And then the particular categories are the same. An X in region 2 for some S are P, and an X in region 1 for some S are not P. Make sure you familiarize yourself with the distinction between the modern interpretation of categorical logic and the traditional interpretation, and certainly try your best to memorize the placement of these categories on both interpretations on the Venn diagram. Now let's review one of our immediate inferences, which is the move that we've called conversion. Remember that with categorical propositions, there are certain types of propositions that allow us to transform single sentences into their logical equivalents. In other words, to generate a sentence that logically means the same thing, even though the relationship of the subjects to the predicates might be different. Remember that conversion is valid for E and I claims. It is valid for universal negative and particular affirmative claims. So what is the first step of conversion? We are going to switch our subject class with our predicate class. We're just going to flip-flop them, as it were. Conversion is only valid, remember, for our A propositions through limitation. In other words, on the square of opposition, we find our corresponding I proposition for any I claim, and then apply conversion to the particular affirmative. So you can't immediately apply conversion to universal affirmatives. You have to first limit the scope of the proposition by transforming it into its I proposition and then switching the subject and the predicate for that I proposition. So we have two steps when it is an A proposition. We infer the corresponding I claim through subalternation on the square of opposition, and then we switch the subject and the predicate terms on the I proposition. All right, so just recall that if you're struggling with this, what we're really talking about is our square of opposition. Oop, this is very sloppy. let me try again. For on our square, we have our A claim up here, all SRP. Through subalternation, we transform it into the I claim. That becomes some SRP, and then we apply conversion to the I claim, some PRS. And then that's a valid process of conversion. Remember that conversion is never valid for our O claims. Our particular affirmatives over here on the far right can never validly be converted. That is not an immediate inference that categorical logic allows us to make. So be on the lookout for those O claims when it comes to conversion. So let's look at some examples. No SRP. This is an E claim, right? The E claim gets converted to no PRS for any content in the world. I want to be clear about that. The great thing about these moves is they really are generalizable across content. As long as the form is taking the structure of a universal negative, we can make that immediate inference. If we start like this, all SRP, we have to think about how to do this. We have to limit the A claim, all SRP, to the I claim, some SRP, and then we convert the I claim, which becomes some PRS. Notice there is that intermediary step that forces us to limit the universal through subalternation. Then that final move there, some PRS, is a valid conversion. Now let's talk about aversion. Just to review, aversion gets a little bit trickier than conversion, I think. The easy thing, though, is that aversion is valid for all four types of categories. A, E, I, and O allows us to validly avert the proposition. There are two steps to aversion. First, we change the quality. So affirmation becomes negation. Negation becomes affirmation. And then we add the complement to the predicate. And if you're struggling to remember what the complement is, we indicate the complement simply with the term non, right? We add non to the predicate to indicate essentially everything in the world that does not go into the predicate class. It's kind of a strange term, and it's often clunky and non-grammatical, but in logic we can recognize the non-existence of entities in the predicate group. Okay, so I think the tricky thing with aversion first is to not confuse the transformation of quality with quantity. We're not changing quantity, and to not confuse the complement with negation. To say non-predicate is different than to assert negation. So here's an example. Here's an initiating obvertend, all SRP. Ask yourself, what is the category here? This is an A proposition, right? This is our universal affirmative. So how do we change this to the obverse? We have two things to do. We have to change the quality, and then we have to add the predicate, the complement to the predicate. So try to write down the transformed obverse of this A proposition, all SRP. What would it be? If you wrote no S or non-P, you are correct, right? Affirmative becomes negation. We've switched the A to the E. In a way, I like to think of it as we're just bringing the A proposition over to the E proposition on the square of opposition, and then we've added our complement non to the P group. So this is a valid instance of obversion of an A proposition. Contraposition. This is the last of the inferences that we're allowed to make here. Contraposition is valid for A and O propositions, so the contradictories on the square are applicable in this case. For E propositions, we have to similarly use limitation. We have to, through a process of subalternation, bring the universal negative down to the particular negative in order to generate a valid contraposed E proposition. All right, so there is that intermediary step again. I propositions are never validly contraposed. We can never apply contraposition to our particular affirmative categories. Okay, So there are two steps to contraposition. First, much as we did with conversion, we're going to switch subject and predicate. Okay, those get flip-flopped. And then we add the complements to both the subject and the predicate. We have to add non to both class terms. All right, and that can end up generating some awfully awkward and clunky sentences, but they are logically valid. For limitation, we have three things we have to do when we're beginning with an E proposition. We have to first bring that E proposition down on the square, right? If we have our square of opposition here, and we begin with an E proposition, universal negative, through subalternation, no S or P becomes some S are not P, right? And then once we have our O proposition, we can apply the remaining steps. We switch S and P, so some S are not P becomes some P are not S, and then we have to add the complements to S and P. And this gets tricky because we already have negation in there. So when we have some P are not S, try to write for yourself the finally transformed step 3. How do we add the complements to some P are not S? Here's the final answer. We need to retain our particulars, so we have some, excuse my handwriting, some non-P are not, we need negation, and here's the tricky part, non-S. This is the final obverse for our E proposition. Some non-P are not non-S. I know that sounds like a terrible number of negatives, and it really is, but this is a logically valid final contraposed form. Okay, so remember to hold on to both the negation, not, and the complement for S, non-S. If we only have the complement, it is not the same thing. It means something very different. So do be wary of that as you're proceeding. All right, here's some examples. All S are P. We're beginning with what type of category? This is an A group, right? This is a universal affirmative. The A group becomes all non-P are non-S. We have switched S and P, and we have added the complements to both terms. No S or P. Recall this is an E, so we have to limit through subalternation. This becomes some non-P are not non-S, as we just discussed in the last slide. Now I want to have a look at applying our immediate inferences to the Venn diagram. The Venn diagram allows us to, in a way, visualize the relations of logical equivalence that our immediate inferences are meant to be unpacking. So the Venn diagram illustrates the validity or the invalidity of our immediate inferences. So when we're looking at conversion, remember on the modern interpretation, we're not interested in the existential import for the subject class. For the A group, all S are P becomes all P are S. This is an invalid inference on the modern interpretation. You will note that this is invalid because if we begin with our convertend, we have shading in region 1 to indicate the non-membership of any entity in the subject group, but the converse indicates shading in region 3, all P are S. There can't be anything in the P group because everything that is in S has to, in a sense, everything that is a P has to be included within S, as is indicated by the converse of the A proposition. So really, this just gives you a visual representation that's very immediate of why these sentences are not logically equivalent. They're just telling us two very different things. So we cannot convert by limitation on the modern interpretation. If we have a look at E propositions and the conversion of E propositions, you will see that this is a valid inference. The converse is logically equivalent to the convertend. So if we begin with no S or P, we have shading in region 2. There is no member of the S group that is, there is no member of S that is also a member of P. And to say no P or S is also to say that no member of P is also a member of S. So we have total logical equivalence for the E propositions. This is a valid inference. So conversion, we know, applies to E propositions. All right, and the Venn diagram, this is not really giving us new information. It's just another route through which we arrive at the conclusion that the converse for an E proposition is a valid inference. Okay. For the I proposition, we similarly have identity here, right? We have the exact same thing. For the I proposition, some SRP, we have an X in region 2 here to indicate the membership of at least one subject in the predicate group. And then to flip subject and predicate for the converse, some P or S, we need an X also in region 2. There is at least one member of the predicate group that is also a member of the subject group, and region 2 is the only place that denotes that. So this is logically equivalent. These two statements are logically equivalent, and so conversion is always valid for I propositions. Again, no new information here, just essentially a visual representation of why conversion is always valid for I propositions. Okay, so try to familiarize yourself with the Venn diagrams for these moves. Now, why is conversion never valid for O? Well, if we look at how they're placed on the Venn diagram, we have a particular in region 1, some S are not P, right? It has to be excluded from regions 2 and 3 to indicate that there really is some S that is not a P. But then if we look at the converse, some P are not S, we need the reverse. We need a particular that is definitely excluded from the subject group. Well, these are not the same then. These are not logically equivalent. So the O proposition is not a valid converse, right? These two Venn diagrams are not the same, right? So where we have difference, we have invalidity rather than validity. That's another way of thinking about it. So the Venn diagram just makes explicit why the O propositions cannot be validly converted in this way. All right. Here is the full set of Venn diagrams for conversion. This Venn diagram breakdown appears on page 202 of the Baronet textbook. You will see that the categories that can be validly converted, as we discussed, are propositions E, the universal negative, and the particular affirmative. There we have logical equivalence for no S or P becoming no P or S, and likewise some S or P becoming some P or S. These are valid inferences. We do not have logical equivalence for the A and the O group. A becomes all P or S. On the modern interpretation, this is not logically equivalent. And for O, we have some S or not P. The converse is some P or not S. These are not logically equivalent either, and so conversion for O propositions is invalid. All right. I encourage you to draw out the diagram for a conversion a couple of times so that you can become familiar with the placement of these terms, to become familiar with the difference between universals, where we need shading, and particulars, where we need X's to designate the member of at least one group. Okay? Now let's move along to obversion. Obversion, right, deals with the transformation of quality and the addition of a complement to the predicate. If we look at the A proposition, you will see that the obverse of an A proposition is logically equivalent. All SRP becomes no S R non-P. And on the Venn diagram, we have identical shadings in region 1 to indicate that there's nothing out there in the S group. Remember that for obversion, all 4 types of categories are valid. So we should expect to see logically equivalent Venn diagrams for all 4 proposition types. And indeed, the A proposition looks equivalent to me. We then move forward with the E proposition. No SRP becomes all S are non-P. So this is how you diagram all S are non-P. We need shading in region 2. Everything that is an S is also not a P, so we can't have anything in that area of overlap. And we do have logical equivalence between the obvertend and the obverse. So E propositions are always validly obverted, and the Venn diagram does show that these are identical, right? Okay, these are universals, so we have shading. Now we're moving on the obverse to particulars. For I propositions, our particular affirmatives, we begin with some SRP, and the obverse of the I proposition becomes some S are not non-P, and we do have logical equivalence here. In order to indicate some S are not non-P, we need an X in region 2 to indicate that there is at least one S that is definitely not a non-P. I know that is a little bit logically quirky and a little bit semantically difficult to follow, but that is the visual representation of some S are not non-P. Remember, we need both negation and the complement here to retain the sense of the O proposition. These are logically equivalent, so I propositions are always validly obverted. They are the same in essence. Finally, we have our O proposition, our particular negatives. Some S are not P. We have an X in region 1 to indicate that there really is at least one S that we know of that's definitely not a P. It's definitely excluded from regions 2 and 3. And the O proposition obverse becomes an I proposition with a complement. Some S are non-P. There really is one S that is definitely excluded from the P. So another way of thinking about this is that these two sentences are, logically speaking, saying the same thing. To say some S are not P pretty much amounts to saying some S are non-P. They are logically equivalent. And the Venn diagram is just a way in which we can visually capture that equivalence to ourselves. All right, so obversion is very flexible. It allows us to apply it to all 4 types of category. Here's the full Venn diagram list for obversion on page 203. Try to get comfortable with this. You will notice again that there is perfect logical equivalence for all 4 types of proposition. There is no differentiation from the obvertend to the obverse, right? Shading in region 1 for A, shading in region 2 for the E, and then we have in our particulars an X in region 2 for the I proposition. The obverse some S are not non-P yields an X in region 2, and then for our O propositions we have an X in region 1 with the obverse I proposition some S are non-P in region 1. So obversion is pretty straightforward on the Venn diagram. Last but not least is contraposition. How does this look on the Venn diagram? Remember that contraposition involves 2 transformations. First, we switch S and P, and then we apply complements to both S and P. Contraposition is valid on the modern interpretation for all A propositions. If we begin with the universal affirmative, all S are P, we have shading in region 1 to indicate that there is nothing out there. And then to apply contraposition, we switch S and P and add the complements to both groups. So the resulting contraposition is all non-P are non-S. I know that is a total mouthful, but if we visually represent it, we need the exact same placement of shading in region 1 on the Venn diagram. So these are perfectly logically equivalent sentences, even though they might sound to common sense to be saying very different things. But at the level of logical structure, these two sentences say the same thing. Okay, so get familiar with the A proposition's placement on the Venn diagram. For the E proposition, things get a little bit trickier. Remember that E propositions cannot validly be contraposed, and they cannot be validly contraposed even through limitation on the modern interpretation, because the modern interpretation does not have this issue of existential import. So contraposition is always invalid for E propositions on the modern interpretation. You can see this in the Venn diagram, where we begin with the E proposition, no S or P, where we have shading in region 2. The resulting contraposed sentence becomes no non-P or non-S. And the Venn diagram for that sentence is shading in region 4, which is completely outside of regions 1, 2, and 3. And that is not logically equivalent to shading in region 2. Okay, so things do become a little bit more convoluted on the modern interpretation to a certain degree, in that we cannot apply that nice trick of limitation to limit the scope of the universals. Okay? I propositions are always invalid for contraposition. We cannot validly apply contraposition to our particular affirmatives. If we begin with the I proposition, some S or P, we need our X in region 2 to indicate there is at least one S in the world that is also a P. But if we switch S and P and then add the complements to S and P, the result is some non-P are non-S. The only way to indicate that on the Venn diagram is to have an X in region 4. We need the existence of at least some non-P that is also a non-S. The only placement for that X is in region 4, completely outside of our regions 1, 2, and 3. And that is logically not equivalent to region 2. Okay, so contraposition is not a move we can apply to the I propositions in any instance. Okay. O propositions, however, allow us to apply contraposition. If we begin with our particular negative, some S or not P, we have an X out in region 1 to indicate the existence of at least one subject that's not a predicate. And then if we apply contraposition, we flip-flop S and P and apply or add the complements to both. The result is an O proposition. Some non-P are not non-S, and the only designated place for that X is still region 1. These are logically equivalent sentences. I think it's perhaps the hardest for students to apply contraposition to the O propositions, perhaps, because we need to retain that negative in our copula, are not, while still adding another complement to the subject group, as we've discussed, right? Hold on to are not, even as you're adding another non to the subject class. Okay? So O allows us to contrapose. Here's the full set of Venn diagrams for contraposition. This is on page 204, once again. Notice we have logical equivalents for our A propositions and for our O propositions. Those are the ones that we are allowed on the modern interpretation to apply contraposition to. The E category, however, as well as the I category, does not allow us to make that move. And you can see the non-identity or the lack of sameness, as it were, on the E and I propositions. Again, try to acquaint yourself with this set of Venn diagrams. Draw all 4 categories at least a couple of times so that it starts to kind of internalize with you. And then we'll be able to use these all the more readily as we look at some content. Okay, that is enough for now. We will proceed a little bit with just a few extra ideas from categorical logic in the next video. But before you make any further headway, before you look ahead, make sure you understand the Venn diagrams and what they're showing and how to apply our three inferences: conversion, obversion, and contraposition.